Hello everyone, my name is Ashish Nanotkar. So today's session's objectives, we would be learning on why DevOps, why to use it in the first place. What is it? What are the market trends about different tools or the job trends as well? Okay, most of the people here would be interested in knowing if I switch from my current job profile to another job profile, would it be beneficial? Should I even invest in DevOps? My money is a different thing, but time and valuable brains you would be racking. Okay, so should we be doing it? Another one is the skills required for you to be a good DevOps engineer. I will help you understand what is required and when it is required. You might not need all the skills all the time, but it is always good to be an all-rounder rather than getting stuck on some of the points. Most important is going to be the DevOps delivery pipeline. That's what we are here. Okay, so we would be talking a lot about DevOps delivery pipeline. What are the different components? What are the sections, the tools that form it, concepts that we deliver using that pipeline. So in different companies, or even with the same company with different projects, it could be different. Okay, so people would be using different tools. They would be building the stuff differently. They might be using branching. They might not be using it. They might be using Jenkins or some other one. They would be testing product the different way. Someone might like to do it with JUnit, another one, since it is a GUI product, might like to do it with Selenium and something like that. Okay, stuff varies. So it's not a silver bullet that we are building here. I'm here to help you understand the concepts, and then we'll be talking about what the problem statement is. We would be taking up one problem statement, and that problem statement we would be continuing till the end. So I'll talk about a problem that this is what we are going to solve in next 7 classes, so that you have a clear picture of where you're heading, plus the stuff that you want to keep in between, or the steps that you want to build in between. So you can come up with your own plan. Every DevOps engineer who is responsible for building a solution is in control of himself. Okay, so whatever he says that I want these steps to be taken to reach there, it's totally fine and it would be correct most of the time. Paths can be different. You can think a different way. I can think a different way. Someone else would be coming up with a different solution. It's totally fine. And we appreciate that. So anything that you build by end of this complete course would be evaluated and you would be given a practice certificate based on that. Okay. Why do we want it? Why should we learn it in the first place? Okay, DevOps is a new word, but DevOps is not a new thing. People generally mistake DevOps with automation. They get mistaken when they say I would be using Puppet or Chef, so it's not DevOps, right? Like I told you earlier, it's a cultural shift that you want to work on. If your company is doing cultural shift pretty much awesome, okay, everyone is happy with that, so they can do DevOps only using shell scripts if they want. I've seen people do very good automation using just their shell scripts and rsync for deployments, so it works, right? But here we would be standardizing ourselves because we don't want to reinvent the wheel. Now see, whenever you want to automate something, you would like to find patterns, right? If there is no pattern, you cannot automate it. That's the problem. So even with artificial intelligence, when you say it's an artificial intelligence, robots can think. No, they cannot. They are fed with some artificial, as in some patterns of thinking, and they keep on mixing and matching it. So that's the algorithm. Here in DevOps as well, we automate based on a couple of patterns. And let's see what those patterns are. So you must have learned about waterfall model back in your college days, right? So what is a waterfall model? It includes a couple of steps that everyone has to follow in order to get the software out. Okay, it's a staged paradigm. So what happens is you build your software in various different stages, and those stages are then followed by yet another stage. So output of one stage is acting as input for another one. But your whole software moves through it. Okay, instead of moving the complete software through the stages, people have came up with a brilliant idea of implementing Agile. Fine. So Agile is good. What Agile allows you to do is to keep your software in always updatable and deployable state. It also means that you need to test your software multiple times. It also means that your software has to be built in incremental fashion, one chunk at a time. Not a complete software can be built overnight. A couple of lines of code, test it, deploy it, check it. But that comes with its own problems. You need to do the stuff multiple times a day. Okay, so development is fine. Developers are paid for that. They develop all day long. But testers, they need to test the same feature 1,000 times a day whenever it is released out, along with the incremental features, along with the regression lines. So it's not possible. We need to automate that. At the same time, when you are moving the code at that pace, you need to make sure that people are not polluting your code base. They are following the standards. Okay, so in hurry, they should not be overlooking something. So there needs to be a standard solution for that. All right, that's the reason why we have brought in automation to help with everything. And when I'm saying they should not be overlooking it, it's a cultural part, right? You should not be overlooking it. It's not a process that we keep in there. And what's the difference between a process and a culture? Okay, many of you must be developers. So when you develop something, you write some code and then you check in your code in Git. Okay, I'll talk about what Git is, what version control systems are. But for now, let's say you want to move the code from your machine outside to the world, to the public. Okay, so when you do that, you first need to test it on your machine. Then you need to commit it. Okay, or if you are in a bigger organization and your code is critical, you should get it reviewed from someone else. That, hey dude, I have written this. Can you please check it for me? It's not like a teacher kind of check. He's not giving you marks, but you just have another pair of eyes look at your code to figure out something that you have probably overlooked. All right, so that has to be there, and it's not on checklist. So nobody gives you a checklist that you need to write the code, then you need to test it, you need to build it, then you need to package it, then you need to review it again, test it again, then commit it. No, nobody gives you a checklist. That comes as a culture from you. That's why people bring in employees who are already experienced, because you bring in some culture with you, right? So that culture cannot be forced, but that can be put online in the pipeline, and that can be made mandatory using the tools. So that's where we bring in these tools. So we say, before you commit, I want to test it. Or let's say if you have committed before moving it to the master branch, I need to test it. So who is going to do it? There is a solution for that. So they have created a nice bot. Okay, and that bot makes sure that whenever a check-in happens, we automatically test it. And to run the tests automatically, there has to be some tests. Okay, you cannot do everything manually. So that's another cultural change that we want to make, that manual testing has to go away slowly. We want to automate everything. So there has to be a test case. There has to be a code coverage statistics. When you bring something from human to machines, human can say, I have tested the code completely. When he says completely, does he provide you with the statistics, how many percent? No. When it goes to a machine, and machine cannot tell you how much code it has tested, so it has to be calculated. So there is some statistics according to that. And in DevOps, we do talk numbers a lot. Okay, since we are moving from manual stuff to automated stuff, we talk numbers. So we say earlier your code was having, let's say, 50% of code coverage, as in the test cases that you have written, they only test 50% of your code. And then we have written some more tests, some more scenarios are covered. And when you execute your program, all of the lines of code are actually executed. So your code coverage increases from 50% to, let's say, 95%, 96%. That's the statistics that we talk of. And every single step that we build in DevOps is a statistical step. Okay. So that's good, and that's good to remember as well, that we should be having statistics at each and every point in the DevOps pipeline, or development pipeline, or release and build and release pipeline, whatever you call it. So here what we are going to do is we are moving away from waterfall. We are embracing Agile, but Agile has its own problems. That's why we are trying to remove the redundancy and support the culture by automating it using the tools. And since this culture is very much common all across the globe, so whenever you see an IT company, pretty much everyone tests their code before pulling it out to production, right? So if they do so, we take up a concept. The pattern is to test the code, right? That's the pattern. You test it using any tool you want, or simply write a script for it if you don't want to use an automated tool, if it is too big for you. But that concept has to be there. So build, test, deploy, and again reiterate. So you'll be reiterating again. At every level, there has to be a feedback loop. What's a feedback loop? So see, here in the stages, requirement gathering, system design, implementation, testing, deployment, and maintenance. If you see here, the output of one is getting into input of second one. Okay, if second step, let's say on the implementation phase, someone figures out that the design wasn't proper, that's why we are stuck at this particular level, they would shout back. And this shouting back is not quick enough. Generally, when waterfall model was being used, different companies, or rather different teams were brought into picture. Testing team was completely different. It had nothing to do with development. They never knew who the developer was, and the complete software was given to them or a different company to test. And after a couple of weeks, couple of months, they came up with a big report that, hey dude, these things are not working, you need to fix it. All right, that's fine, but during that span, a couple of months later, the developers who were actually working on that code, they forgot, right, what they were working on. And that literally happens. Do you remember what you ate 2 nights back? No, you don't. So how do we fix this? We don't allow any developer to change the context. And changing the context, as in, how long does the person remain in the same context? A couple of minutes. Let's say writing a code, 400 lines long code, and I've tested it. It works for me because I'm testing just the one feature, and I'm pushing it away. So when I'm pushing it off, there needs to be a software that tells me that something is wrong with your code. Instead of testing just one feature that I did, it would be testing all the features, all of them. So if I'm breaking up someone else's code or someone else's feature, the software, that testing engine would tell me. Okay, and it would test it so fast, in a couple of minutes it would revert me back. It would say, hey man, you have broken this particular code, it works for your feature, but someone else is actually crying, so I don't allow you to move it to the master branch. So fair enough, I'm still working on my laptop, I'm happy to receive an email in a couple of minutes, and I know what I was doing, so I'll fix it. That's soon enough, right? That's called a feedback loop. And that feedback loop is, right now I've just told you about the testing part, but it can also be at the deployment stage. It can also be at the after deployment stage and monitoring stages. It would just not be a notification to me, but it can also be a notification to the system. So we would be having a system which will automatically scale up and scale down depending on the traffic. So let's say your traffic is 80% and more. So, okay, what do I mean by that? Yeah, I mean that your CPU levels are actually surging high to 80% on all of the machines. So that would trigger a notification. And that triggered notification would add a couple of more machines to your network automatically. Okay. So instead of managing a runbook for ourselves, runbook is just a couple of steps that one needs to do in particular scenario, is generally observed by the ops guys, but you could have a runbook automated, okay, to carry on these steps. So there are a lot of stuff, but if you see here, we are just supporting a different kind of culture, right? That's why DevOps is also called as complementary part of being agile. So if you're agile and you don't have DevOps, you cannot implement agile in a fully efficient manner. If you have just DevOps and you're not agile, then DevOps would not help you. If you automate everything but still work along with the waterfall model, then what's the use case of it? And why do you use so much automation in the first case when you're not automating anything, right? So it needs to go hand in hand. So perfect use case would be a project to which changes are coming in very frequent, and you need to deploy it to production very frequently. Very frequently as in couple of times a day. If it is at least one times a day, it's fine. But if you deploy with a gap of 3 days, a week, 2 weeks, no, it's not DevOps. So the whole idea of doing this automation is to remove the pain points from the ops side, which are actually resistant to changes. So what these people do is, so it's a fair idea actually. Say something is working just fine. Why would you want to change it, right? Something is working just fine. Why do you want to change it, right? Let's say I have tap in my home which is working fine from ages. So it's working fine. It's no problem. Other taps have been changed much frequently, but this one is sturdy one. It doesn't break. It's cool. So it is working. Why do I change it? Fair question, right? For the ops guys as well, the code that was working initially, if it is working fine without any errors, why do I change it? And it's not just about code. When I change the code, I need to change the database schema. When I change the database schema, I also need to make sure that the logging is proper. I need to make sure that the queries are not impacted. The response times are good. Okay. I need to make sure that the new code that I have dropped in is properly set up. And if it is not for the same machine, I need to bring in another machines. So this whole drill takes a lot of preparation for the ops guys. That's the reason why they resist it. Okay, they have got a lot of teams for different sections. So for Ubuntu, they would be having different. For CentOS, they would be having some different support team. For databases, a different support team. And since it is a completely different team, it's a silo. So they need to go through all the approval levels, shoot in a mail that, hey buddy, I need to deploy my code next month on 2nd of Jan. Okay, so be ready for it. So he would say, no, we are having some different work to be carried out during that window. So it's a lot of work and it's a big event for them. We don't want this big event to be reoccurring. What do? We automate it. So once you automate it and you're doing it 100 times a day, it's not a biggie for you. But how do you do the same thing 100 times a day reliably without failing? Okay, and having everything automated right from deployment to rollback in the worst case scenarios. Okay, that's what the thing is. All right, there's a question here from Mr. Basu. The question is, can you give more example of runbook in a development scenario? Yeah, why not? See, in development scenarios, when you build something, you would like to revert. Okay, if it fails, you would like to revert. Or you could think of something, but actually in the development environment, I wouldn't recommend you to use a runbook there. If it is a container you want just to test, apart from the code development, okay, apart from the code development, if you want to test it locally on your machine, if it goes right, you commit it automatically. If it doesn't go right, you keep the container and inspect it. That can be an example of a runbook for you. It can automatically be implemented using a script. Okay, I hope that helps. But the actual coding, I wouldn't recommend you to do anything automatically on your code. So there has been a lot of adoption in DevOps after 2009. The latest development being in 2014 onwards. Okay, sorry for another question here. The question is from Mr. Basu again. Is JUnit a runbook? No, I wouldn't say it's a runbook. It's just a test framework, right? A runbook is a scenario that you build. It's just a scenario. It's not for testing. It's a scenario that you revisit if something has happened, the problem. If the problem statement arises, you go to the runbook, figure out where's the problem and what are the steps to fix it. That's what the definition of runbook is. Okay, so JUnit is not a runbook. All right. So from 2014 onwards, there has been a great exponential curve, like a J stick. Okay, here in DevOps adoptions, and there's a lot of traction that is being seen in market. That's the reason why a lot of people are moving from non-DevOps world to DevOps world, moving their profiles. Okay, it seems to be cool, but it has been in picture since long. Has anybody tried to search for DevOps jobs at Google or Facebook or Netflix? You wouldn't find one because there is no DevOps there. That's the nirvana level of DevOps. So there would not be any DevOps when you reach the final stage. That's what I told you, right? That is the level. So once you automate everything, your culture is it's proper. You don't need a DevOps team anymore. So automated ops is not DevOps. If you use a tool to automate your ops thingy, it's not a DevOps anymore. Okay, it has to be on the both sides. So these days, people are realizing it. Actually, Agile is also dead. There's a new concept called Model Agile, which is based on just 4 points instead of the 12-point manifesto, which was released earlier. It happened in late 2014s, early 2015s, almost 2 years now, 1.5 year to be precise. So, but it's fine. If it works for other people and they are adopting it slow, it is totally okay if it works for them. So now we need to support that transition. Hence, we are learning what we are learning here. Okay. There's a question here from Dinesh. The question is, we have a release and deployment cycle, which is monthly and quarterly. Can DevOps help here? Usually when module is deployed, at times we miss some components. Also at times, a few months after deployment, some of the components are missing in some clients' machines. Can DevOps help here? Sure, it can. And you should be adopting that anytime sooner. Okay, so DevOps can help you do this. Instead of deploying and releasing it monthly, you could make it more frequent. Okay, you could create a small client or a script which will make sure that every related component and dependencies are pulled before you configure something on your client's boxes. It can be automated. It should be automated in the first place. I don't know what your product is, what the modules are, what the technicalities of it is. You are the best person to figure out the solution for that. But yes, you could do that. Question from Hema that I'm working as a virtualization admin. How can DevOps help me to enhance my career? Since you're already in virtualization, you are in a part where you would be like nimble enough to provide multiple machines or environments out to the out people. Now, when we look at the CD part of it, okay, CD part of the pipeline, then we need a lot of infrastructure to be built. That infrastructure, since you're a virtualization admin, you know there would be different components apart from just virtual machines to virtualization. Now, all of these would provide you with an API as well. That API can be programmed, okay? So once you program everything using that API, you could put it in a nice bot, something like Jenkins, that will help you out. So instead of you doing all the virtualization work, Jenkins would be doing it on your behalf. So automate that, right? That can be automated. You must be doing it right now as well, but not on in the DevOps fashion, but you could do it once you finish with this course. You see how Jenkins would be doing stuff for you. You can move it on. I hope that helps you. But as a career, it's awesome to move outside of just virtualization because it's just one of the small chunks of DevOps thingy. A complete DevOps engineer or end-to-end DevOps engineer would be the one who knows how to write the code, who knows how to test it, who knows how to build it, how to package it, how to test it again, then deploy it somewhere, again do some testing there, along with the statistics, then move it onto production, create the infrastructure, configure it properly, okay, and make everything that you have done apart from coding redundant. Okay, you could get past any of the catastrophic effects. Let's say your Jenkins blew up. Instead of shouting who did it, you should be able to bring it back in minutes. One of the machine on your production systems died. You should be able to get it back. Okay, not from the backup again. So it's like do something which will help you to prepare yourself in failures. So if something fails, you should be able to get it back without shouting. Okay, that's what the end goal of it is. So you need to learn a lot of things to be an end-to-end DevOps engineer. Plus, you need to have an experience about different architectures, different deployment strategies, different solutions for different business problems, because not all the businesses are same. Everyone likes to run their business their own way. Okay, so solution has to be crafted according to them. So it's always a good idea to know a little bit of scripting, some coding. It's always helpful because tools wouldn't always help you. Not all the tools would fit in your organization. Let's say my organization would be a small organization, let's say. So I'm consulting for that, and we are not running more than 15 machines in production. So would I recommend them to use Kubernetes for the controlling all the containers? I would not, because it is overhead to manage just Kubernetes on 4 another machines, adding almost 40% to the budgeted value of the infrastructure. It doesn't work for me. I wouldn't recommend using Puppet or Chef. It's too bulkier, too heavier to manage it in high availability systems. So I would not recommend that. I would hop the tools. I would switch the tools. Okay, concept being the same, I would use something else. So you get an idea, right? So that's the end-to-end DevOps engineer for you. If you are low on a couple of skills, I would say just help yourself with that. Okay, ramp up. I'm here for another 1 month, so it's a good time. And if you want to practice it literally, at least spare 2 hours a day for next 30 days. So that's ample amount of time for you to practice a lot of stuff which has been covered here. Apart from the slides, you could also jump onto any other tool you want and bring in the questions after the class. It's fine. Question from Mr. Venkata. The question is, how feedback loop is used in an organization? Okay, there would be different feedback loops, a lot. Okay, more you create, more you would be able to tell what's happening in your CI/CD pipeline. So first feedback loop happens right at the commit level. If you're committing something and your code is not sanitized, you are missing a semicolon, that commit would itself check that the code is a faulty code and it wouldn't run, so it wouldn't allow you to commit. That's the first feedback loop. Then that's the smallest one. You get to know about that particular problem right within a second. Okay, that's the first one. You get along. If the code moves through the commit section, it would check for the coding standards. So if your organization needs a space between closing parentheses and opening parentheses when you don't pass a parameter, you have missed it, it will tell you back. Now this time it would mail you, or it would IM you, or send you a direct message. So that's another feedback loop that you can create. Now, feedback loops can be of different types. The commit level, at the testing level, Then at the deployment phases, after deployment, if the performance is not right, it is not within the brackets that you have set up, it would tell you that, hey buddy, after this change, the performance has actually decreased by 20%, and you just have a tolerance level of 3 or 4%. So it would tell you. Nobody thinks of it, right? When you deploy the code online, it moves to the production, and nobody actually figures out that after a particular feature has been deployed, how much extra load is being generated on the machine, on the production, how much response time has been decreased by that or increased by that, what is the impact of it. No one tests it apart from really, really nice big companies where they don't have any DevOps jobs. Okay, you should be doing it. So at different levels, there is a feedback loop. On the infrastructure side also, if one of the machine dies or your logs are getting blocked, there is a network congestion. So there are sensors. I wouldn't call it a literal physical sensor, but it's just a software program which tests the state of your network, the state of your machine, the state of your disk, the RAM, the CPU, different boxes. And it would send you some logs back, some notifications back. But based on that notifications, there's a bot that takes care of notifying you. Okay, so that bot does some calculations, some math, and it sends you back a notification. So any computer system has got zero IQ, you know that, right? So you need to write a program for yourself. Or if you don't want to write it, search for someone else's program. So the tools that we are learning right now they have been evolved as a solution to some of the problems. And since we find ourselves at the same location, same position, that I'm also facing similar kind of problems, so let's see if this solution fits in for me. Okay, and in most of the cases it does. That's why that's the reason why we are using these tools like Jenkins or Puppet or Chef, because we find ourselves at the similar side of the problem statement. Right? I hope that answers the question. Question here from Nagendra that once automation suite is created by QA and handed over to ops, they will continue to run the automation. Then what is the role of QA in this DevOps lifecycle? Yeah, good. This is the most mistaken scenario of all. People generally think that testing has little to do with it, but I would say testing is most important part of any CI/CD pipeline. The first reason why you create CI/CD is to automate testing, right? It's never been handed off to any of the ops guys. DevOps is not set up by ops guys, so it's never been that so far. So once your test suite is created, that has to be automated. So creation of test suite has to be done by QA, correct? But when you create it, it has also to be run. It cannot be just run just once before deployment. It has to be executed every time someone commits in DevOps or in an agile world, right? Because you need to test the complete code. So testing or running the test suite is not a part of QA's life. The reason for that, because we don't want QA to be just running the test suites. It's just wasting a lot of time and sitting there idle, doing nothing. So it is handed off to your machines. So DevOps pipeline, make sure it is executed. And testing is supposed to be done at different levels. So you have got unit testing, you got functional testing, you deploy the code, then you have your integration testing to be done. After the code is deployed, it moves on to the staging area where it is combined with other modules, third-party services. You again do a regression test there, make sure that it is performance validated properly, and then it moves on. So QA would be a really busy person writing down tests for each and every new feature that is being released in your agile cycle. Okay, so their role comes at various different levels. Anytime you choose to hop a level with your code, let's say you're moving from dev to QA and from QA to stage, that level has to be sanitized, it has to be tested. And who is going to test it? Of course the QA, right? So I hope that answers the question. QA has got a bigger role to play in this complete DevOps lifecycle. Question from Srinivasulu. The question is how to help DevOps at Unix admin level. Well, at Unix admin level, see right now you are working in a silo. That's why you're asking me this question. The best part would be your company allows ops guys to talk to dev guys. Okay, and when they talk to dev guys, they learn how the development is happening there, what are the problems that they're facing, automate the stuff, and get the code continuously rather than getting it at the end. If you want to automate things at admin level, because you're not talking about deployment and stuff, you could really automate everything that you have, right from configuring your developer machines, creating their user accounts, setting up the LDAP boxes or setting up the firewalls and getting stuff routed in and out. But you can do it in a reproducible manner. So instead of coding on the machine directly, or instead of configuring the machine directly, you write some scripts for yourself or use some configuration management tool like Ansible or Puppet or Chef, which can help you address the problem in a nicer recursive way. So let's say your firewall machine blew up, and how much time do you think you would need to reconfigure everything? A couple of hours, right? Wouldn't that be easier if you have already configured something, configured a software to create that firewall system for you? It would do it in minutes. If you blew away your LDAP system, you should have a backup which will create the users again, configure the LDAP machine just like it was, plus reconfigure the other machines which were actually pointing to that. Okay, a lot of things that you could do. So configuration management is something that will really help your life. Does it answer your question? Question from Eric. The question is, what all tools do we need to create a complete cycle like building, testing, deploying, and stuff? Yes, that's coming in the next slide, so I would not jump ahead of me. I'll cover it. There's another question. The question is from Nagarjuna that I'm just a beginner, completed my master's recently. Can I get through this by a month? It depends on you. For me, if you ask me if I were in your position, yes. Okay, that's fairly easy. But that totally depends on how much time you put in. I would recommend everyone to at least put 2 hours of time daily for the stuff that we are doing, plus anything else that you want to learn and come up with questions for yourself. So I really recommend you to do so. Okay, now that we have talked about the waterfall model, the problems that they are, and we also would be looking at what we are trying to solve here. Now, on the cultural part, these are the green things that you see. Would be telling you the pointers, plus the red ones are the problems that we need to solve. So huge waiting time for code deployments. There's a lot of pressure to work on the old code, the pending ones, and the new features at the same time, helping developers switch between the things and at the same time test it. Okay, you need to solve it. Maintaining the uptime of this production environment is the bigger problem. If you fix it for the ops guys, they would be really happy to deploy your code as many times as you want without worrying about the cap and all those kind of just routines. Okay, difficult to diagnose and provide feedback on the product. That's difficult. You need to be in position to monitor everything. But there's a bigger problem than monitoring. If you monitor everything, you get a log, a lot of logs being dumped. You also need to be in a position to analyze those things and tell whether the system is working at a proper state or not. And how do you analyze it? It's not just a couple of seconds back kind of scenario. It's about a couple of weeks back. So let's say a couple of weeks back, I see that the traffic level on my machines rises on Monday, steadily goes down on Tuesday, Wednesday, Thursday, Friday, and drops to 0 on Saturdays and Sundays. That's what my traffic stream looks like. But how would I know about it? I need some analytics engine which will tell me by a nice visualization graph that, dude, this is how your graph looks like. And if this week I've seen the graph drop to just 50% of the traffic right on Tuesday, I would smell something fishy. But how would I know that? Because on the monitoring front, it tells me that all the machines are up and running, everything is fine, the application is running cool, but I still don't know what's the problem, why the traffic went down to 50%. Okay, but in order to figure out why, you need to first know that it happened. Okay, so that's a bigger problem here. You need to have an analytics engine. That's why people have come up with various different solutions. So we have got a solution like ElkStack, Elasticsearch, Logstash, and Kibana. That trio is really awesome in open source world. We have got Splunk, which is a non-open source solution, but it is really awesome. You should have a look at it. There are some paid and hosted solutions like New Relic out there, which will help you do the job just fine. It totally depends on which one you use, but you need to have an analytics engine to give you near real-time, if not real-time, statistics on your current application. Question from Hema. After this course, would I be able to get a job as DevOps engineer? Well, no course can help you to be what you are. It can only guide you through the things. What you need to do is to be done all by yourself. Okay, so this is not a certification that you would be getting a course. You would be getting a job somewhere. For getting a job, you need to work, and whatever is being covered here matches to the job profile of most of the job openings out there. So you know a CI/CD pipeline, you know a solution, you know the concepts, you know the tools, then you can apply for the job. But getting experience on it, it's totally a matter of time and the more you work. Because if you work, let's say, twice as hard, you should be able to chase your dreams twice as fast. And I've seen people who have been in DevOps for almost 4 or 5 years, but they don't know anything. So leaving that part, answer for your question is yes, if you work. Question from Vishal that please suggest most basic tools to start with for a person with no background in ops or testing. Don't worry, this course is all about doing that from scratch. So we don't have any prerequisites. I don't recommend to come from a specified admin or testing or development background. No. If you are a fresh starter, it's still good. We'll talk about the tools. There's a suggestion from Kumar that I think that's where RUM products come in handy. Yeah, they do. Question from Venkat that as a DevOps engineer, one has to focus both on development and operations. Ideal world, yes, but in your company, if they are hiring for automated ops, sorry for that, a lot of people do that. If they are hiring for automated ops, that's not DevOps again. They would want you to be specialized in just one, either Jenkins or Puppet, or they would want you to be working on the cloud part, just specialized in one of the cloud providers like AWS. You don't even need to code anything. You don't even need to learn about Jenkins. You don't even need to know what the application looks like. That's not DevOps. That's bad. But they would pay you handsomely for that. Okay. So as a straight answer to your question, no. But if you really want to be a DevOps engineer, that's a must. You should. Cool. So there are a couple of problems that we have figured out. And how do we fix it? Now see, these problems are very generic. And these problems would be available in most of the industries who are working for IT. So DevOps would help you in automating your infrastructure. It would help you in automating your workflows. Projects would be having different kind of workflows, right? And talking about numbers, so continuously measuring the application performance, not just performance, but also code coverage, the level of testing that you're doing, statistics about how much stress your application can take, how many users, how many concurrent users, how many connections your database can handle, the amount of RAM that is required, the footprint that is there, a lot of stuff. You would get a lot of statistics. We fairly have almost 500 machines or so, and we generate a daily log of almost 55 to 60 GB a day for analysis. That's a lot, I think, right? It's when you talk about big data, it's not even considered big data, by the way. So it's not big data for us, but it's a lot of logs that you need to analyze. And analyzing 50 GB of text files, it's not again a binary, right? It's a text file. You know, a couple of MBs of text file can be difficult to open on a text editor. So how do you analyze those many logs? You need something to do that magic for you. So the challenge is like waiting time for code deployment, automate that. Pressure of working on old and pending and new code at the same time, use branching, use a smarter version control system. Why are you still stuck with something like Subversion? Move ahead. Okay. So what's the DevOps solution for that? Continuous integration. That's the first section of the CI/CD pipeline. We call it as CI/CD. C stands for continuous. I stands for integration. Again, in CD, C stands for integration. C stands for continuous, and D stands for deployment. There is again something called as delivery. Slight difference, but people generally merge delivery with deployment. It's fine. It's not a hard-coded definition anywhere. I'll come to that when we talk about CI/CD. So here, once you set up the CI/CD pipeline, continuously integrating the code with the existing one to make sure that the existing one doesn't break. Okay, that's the whole idea of CI, and that is done automatically using some of the tools. So that's the solution for that. For working on different stuff at the same time, use branching strategies, use a better version control system. We'll talk about one, which is a distributed version control system called Git. We might set it up or we might use the host solution, depends on how much time we got. So tomorrow would be a day when we would be learning about Jenkins and Git. Okay. Managing the uptime. If you want uptime, jump back to virtualization. Why do you want to really spin it up on a hard machine, which is very tough to procure, then set it up? If your machine dies for any reason, you will have to literally bring it out of the data center and then push another one. So we make sure that we use virtualization. So scrubbing of a virtual machine is very easy, right? So you could create one, scrub it off, still have a backup of it on your storage device. You could run it from the backup again. So it's fast, it's reproducible. That's the reason why cloud providers have moved from your dedicated hardware to a virtual hardware. So they would provide you with virtual machine rather than giving you an actual machine. So they call it as an instance. That's virtualization for you. So right now we are dealing with EC2 virtualization, as in the virtual machine virtualization on AWS. The newer generation right now, or later, 3-4 years later, we would still be looking at virtual machines, but at just absolute way. So that virtual machine would be created only for setups like, let's say, something that you don't want to change a lot, a Puppet server maybe, or some machines that need a lot of resources and cannot be moved from one box to another. Something like, let's say, a VoIP server or something like that. Okay, world would be moving from your virtual machines to containers, and the traction has um, already begun. So people are moving from their existing VM architecture to the container architecture, deploying the code there. It's really fast. And trust me, when I say fast, it's blazing fast. If you take, let's say, 10 minutes to spin up your machine and another 10 minutes to configure it and deploy stuff on it, with containers, you could do that in a matter of seconds. Okay, we'll talk about containers a lot, so that you are ready for the future. And of course, for the current times as well, when people are transitioning from non-container to container environments. Tools to automate infrastructure management are not effective. Okay, we'll make it effective. We'll see that every tool integrates properly when with the other one. And if it doesn't, you should know a little bit of coding to make it happen. In a software world, everything is possible, okay? So there just need to be a talent which will make it possible. So configuration management is something that helps you in integrating different sections of your infrastructure together, reconfiguring it again and again, even if it fails, reliably and every time. So we would be learning about configuration management. The tool that we are going to learn is Puppet. Okay. In CI section, we are going to learn a tool which is called Jenkins. And for branching strategies, we are going to learn Git. The number of servers to be monitored increases, so we need to have a solution which is easily scalable. Okay. Client server kind of architectures are generally very scalable because you don't need a server to be interacting with clients. Client would be sending data back. Okay, so we just need to worry about the server. So we would be working with Nagios to understand how monitoring works on a larger scale. And it's difficult to diagnose and provide a feedback on the product. Okay, so for getting the ready feedbacks, again, we need a monitoring. So with monitoring, we also need analysis. Nagios would not provide you with real-time analysis, but it still gives you a fair idea of what's happening. Okay, people generally don't use Nagios for application monitoring. They would use something like your any analytics engine that you have, maybe Elk or Splunk for that purpose, firing the queries and generating notifications based on that. But we will see how Nagios can be used for that part. So I'll show you how to create your own plugins for Nagios so that you could adapt Nagios to your own requirements. And it's easy. It's very easy. All of this stuff, installing and setting up of any of the tool, although I would be covering it, you can find all the material online. And do not rely on any course material which is provided just by any classes. Okay, so don't rely on that because the world moves very fast. Every day you would be having a new version released. Every day you would be having a couple of more articles to read. You need to keep yourself updated, and DevOps is one such field in which if you are outdated for 3 months, you lose a bigger release out. Okay, you will lose your updated state. So you need to be continuously updated. Question here from Siddharth that will you cover patch management and reversal of code check-in on regression sometime during one of the sessions? Are we also going to consider pushing the code on multiple branches and its challenges during the CI phase? I would make it a point. I'll remember this, okay? But I cannot guarantee that I would be able to finish it in time. All right. Maybe after the class we can discuss about it. After tomorrow's session when we cover Git. If not in class, we'll definitely cover it after the talk. At least talk about what the problems are. I'll cover that up. Question from Shiv: why Puppet has been selected instead of Chef and Ansible? Because latter is easy to understand. Okay, I would say for learning curve, Puppet is the toughest of all. And once you know the concepts, you can easily implement that on Ansible or SaltStack on Chef. The documentation part, if you ask me, my own favor, I would go with the easiest first. So the documentations for Ansible are the easiest, then comes SaltStack, then comes Chef, and at the last I would go to Puppet. So if you want to learn Chef, it is really easy. You could learn it in a day. Ansible, even easier, a couple of hours. SaltStack, I would compare it with Chef, and Puppet is the toughest because even if the documentation are very simple, but it is a lot lengthier to understand at the very first time. Okay, so we'll be taking up Puppet, and then if you are interested to match it up with Chef and Ansible, I'll also do that during the Puppet classes. So we were talking about DevOps and answering a couple of queries. The question here from Vijay, that he's from IVR background and can he fit in DevOps? Yes, you can. But for learning anything new and to try anything new, you will have to leave your comfort zone. You cannot take your comfort zone with you and try to fit it into another section. Right? I hope that answers the question pretty much straight. Question from Veera. The question is that we have currently migrated from mainstreams to distributed platform with the stuff running on RHEL. Is it quite? It is quite close, and branching strategies, the deployments, testing, automation is kind of messed up. We do everything manual. Can I ask a question if there is a chance of automating anything, however unique it might be? Yes, you can automate, and you should automate pretty much everything that is built there. Okay. It can be and it should be automated, but you will have to find a way for that. I would not be in best position to answer that question because I don't have an insight about it. And if you want to really discuss about it, you can do it after the class. So I'll park a question for further discussion if you want to have, but after the class, definitely. Question here from Hema that I'm trying to install Ansible from my Ubuntu 12.04 machine. I've copied the RSA key to the host server, but still whenever I try to run Ansible -m ping, command says no host found. The host is not found because you're trying to connect to which machine? It tries to connect to the server by default. In the hosts file, you need to add one more entry which would point to your local host. Okay, and you should be able to connect to it. Question from Jagannath, will we cover the Docker? Yes, there are two modules specifically designed for containers and Docker. So we will be covering it pretty much in detail, including how to deploy stuff, how to work with registries, what are keys, what are images, how to recreate images in an automated way, all of that stuff. Okay, so we'll be covering that. Don't worry about it. All right, let's move ahead. So we were talking about the job and salary trend for DevOps. I told you that it is something like a J-stick curve, but here if you see from 2014 to 2015, it's an exponential one and it keeps on rising. Okay, it would be so for next 2 years, I think. The current traction which is in the DevOps stream, later on it would move to very specifics because everyone would have adopted DevOps by then, or at least know it from the ground level. So people would be hiring in very specifics instead of talking about just complete DevOps, because they would not be talking DevOps then, they would be talking about SREs, okay, or site reliability engineers rather than a DevOps engineer. So be ready for that cultural shift later on. What skills do you need for being a DevOps engineer right now? Like I told you, you need to be an end-to-end DevOps engineer, but for the tooling CI/CD that we are building right now, or any of the job descriptions that you'd be getting, okay, they would be depending on these things. Tools, you need to know Git, you need to know Jenkins, Docker, Puppet, and Nagios, which fall in different categories. So version controls, continuous integration, virtualization, configuration management, and monitoring, 5 different categories. Then comes in your general networking skills, your DNS, HA proxy, DHCP, setting up of web and application servers. You need to do that. Now, web and application servers keep on changing depending on what product you are building, which project you're working for. Technology stack keeps on changing, right? It would not be always Java. It could be Puppet, it could be PHP, it could be Python, it could be .NET. Any language that your company works in, you'll have to automate that, okay? So that part would differ. Other skills which are related to the cultural part, if you are acting as a DevOps transition specialist like I do, you also need to be aware of how to talk to people, how to set up the processes, how to change the processes, what are the drawbacks of changing it too fast, or drawbacks of not changing it at all. So these things, talking to customers, building the relationships with them, getting the empathy count in their organization, letting them know what is the strength and where you should be heading, the IT awareness, um, then your market standards, any of the rules that you need to follow, the guidelines that they are there, you need to be aware of that, aware of various different products which are there in the market. Apart from the tools that I mentioned, there are hundreds of tools, literally, and every single week or two, there would be a new tool which is emerging in market, okay? A new one, which would be doing the job even better, trying to solve some other problems. So there would be a lot of tools out there, but you need to choose the one which works for you. Okay, not because your friend is working on that, because it works for you. It might be the case where the bigger tools would not be a good fit for you, because the bigger tools would provide you a lot of features than they were actually meant for. Initially, configuration management was made for one single stuff, configuring the machine. That's why the name configuration management. These days, configuration management systems would also help you in orchestration, like setting up the cloud, calling the APIs, getting the machines up and running, setting up the firewalls there, changing the load balancer statistics, configurations, all of these stuff. They will help you to do so. But they were not meant for that task initially. Okay, so if you want a specialized tool, you might want to add another tool into this category, which is meant for orchestration, Terraform. It specially does just orchestration. So setting up your cloud environment without getting stuck to one of it. So we call it as cloud agnostic design. So that's one of the other things. There are a lot of stuff to do, but for the beginners, if you need to ramp up on the concepts, this is a pretty good start, which can take you to at least intermediate levels, if not advanced. And other things, they generally come up with experience. Okay. Question here from Eric, that if we use AWS instances instead of VM, is there any advantage, or we would be learning more that way? If you're using AWS, it's awesome, okay? Because anyways, on the laptops as well, we would be spinning up virtual machines. You could do it there. Plus, when you're working with AWS, you'll get to learn more about the ecosystem that AWS provides you, or the products that that AWS provides you to work with. If you have an account, I would recommend you to go with that. But make sure that you have ample amount of resources to spend on it. Because if you keep your machines on for a duration more than 72 hours, I think 750 hours is what it provides in free tier. You would be charged for more than that. Okay, so that's the risk. Other than that, it's fine. Question from Eric again. Please give an intro about yourself and your career experience, how to end up learning this all in your career and where you started. Well, I started as a DevOps. I started as a developer initially, and I was working on a lot of stuff at once. So I started my career as a freelance developer. So I had been working with a lot of technologies. So if you ask me to code in any of the languages which is out there, I should be able to do that. Plus, exposure to a lot of problems, got be experienced in designing solutions to a lot of different scenarios. This was actually a good start for DevOps. And later down the line, I moved on from development to the DevOps side of it. So this side was really fascinating back then. So it's almost 4 years of journey when I moved to DevOps. Before that, I spent another 4 years doing this stuff and building solutions. Not just one particular feature, but I have been involved in end-to-end systems, right from coding of it till deployment. But initially, we were not aware of this term DevOps. We were actually doing it all, right? We were doing everything that requires to be done, including a version control till the monitoring and analytics. But the word wasn't aware. We weren't aware of that word then. But now, since it has been formalized, I could now call myself as a DevOps engineer. Back then, it was just a guy who could literally do everything. So if you are wanting to be a good DevOps engineer, I would like you to be called as jack of all trades. Okay, you should be aware of everything that is going around you. And again, if you have a zeal for automation and you have a zeal for reducing redundancy in the environment that you are in, you can definitely be a good DevOps engineer that way. So let's say in your company, maybe your DBA is spending 5 minutes on a particular tool just for monitoring it. Okay, and he does it on 4 different machines, let's say, 4 different tools. So 5 minutes on each calculates to 20, right? And if he does that work almost 10 times a day, it's his job, right? Monitoring is its job. So he would be doing it 10 times a day, maybe once every hour. So he's spending how many minutes do you think? 200 minutes. So out of the 200 minutes, if you calculate it in hours, it would be 3.5 hours fairly, right? So if he's spending 3.5 hours a day just monitoring, because he has to log in into 4 different machines and then look at the logs and then figure out the stuff. Being a DevOps engineer, you could create a small tool, right? That will pull up the data from all of these 4 machines and put it on one single dashboard, which he can view in one single minute. So you're saving him 199 minutes of his precious life. And you're doing it not just for him, but for the complete company. A new DBA joins in, you would be doing it for him. This is where the return on investment for DevOps comes in. A lot of stakeholders would ask about, how do I get ROI on the DevOps? If I invest X amount of money on it, and you say that your DevOps transformation would take anywhere between 6 months to 18 months, how do I get return on investment? I don't want to wait for that long. So this is how it generates money for you. It doesn't pay you off directly. Cool. I hope that answers the question. Okay, there's another question from Nirpendra. The question is, will you be helping us in doing the stuff with Elk? Yes, of the classes. Okay, if it is not covered here and you want to try it out, I can help you out with Elk Stack as well. Okay, so it's true for any other tool that you want to learn. In matter of next 30 days, ask as many questions as you want and take me to any depth you want. Cool. So let's move on. There would be a couple of slides which will help me understand that you are paying attention, although I could also see here on the console who all are actually dozing off. Okay, so let's test your knowledge. Can someone answer this question for me? DevOps movements resulted in something, one of these 3, or waiting time for code deployment is solved using something. Okay, and there would be a couple of questions down there which would not be covered on the slides. Okay, so during that question, I'll also explain you what that actually meant and how do we get about solving that problem. Okay, so the correct answer for here is 1A. So DevOps movement actually resulted in improving the collaboration between developers and operations. We do not put in next team. So people would be bringing in another team called DevOps, and still your developers and operations wouldn't know about one another. So they would be treating your DevOps team as a bridge. Okay, and rather than being as a bridge, it would literally act as a support team, supporting all the developers and operation requests. So turning your DevOps team into a support team is not what you really wanted, right? So this is one of the anti-patterns of DevOps. By creating a DevOps team, you're actually setting up DevOps. It's not. Waiting time for code deployment is solved using continuous integration. We saw that continuously, rigorously testing your code every time the new checking happens, and then making sure that it is always cool, and then moving it out. And that means it's always in a deployable state. Okay, and the big event of deployment is turned into no big event. So it's good. So we do continuous integration there. Question here from Mr. Basu that does not 1A leads to 1C? So improving collaboration and between developers and operations, how would it result in delay in release cycle? It would actually result in reducing the delay, right? So yeah, that's what you meant, but initially your question was a little different. Anyone? Can you answer this question for me? Which one of the following tasks does not belong to configuration management? We haven't talked about configuration management much, but I'm sure you get a fair idea of how it would work. So configuration management, we have been talking about it. It configures the machines for you, right? And increasing the number of servers can be effectively monitored by any of the monitoring systems. And the monitoring system that we have here, okay, it's Nagios. So the answer for 3 is B. It's not C. It helps developer focused on building the current code, and it also proactively manages the infrastructure. Okay, it says it does not. All right, so helping developer focus on building the code is a task of CI, which takes the code away and integrates it properly. Consistently provisioning the system and proactively managing the infrastructure is something that configuration management would do for us. So now getting more technical, what is the pipeline and what are the different components? The pipelines would be very specific to the problem that you're trying to solve, the project that you're building, or the company you're working in. It may or may not have exactly the same number of steps, but logically, sections fall in the same line. Okay, so first section is the version control. Second section would be the testing. You could test any number of steps. You could break it down. Okay, continuous deployment could also fall in various different steps if you want to. Monitoring is automatically taken care of. If you want to configure that in continuous integration, you could also do that, but I would leave it to be away. So this is how the code moves. People generally stack their teams on top of one another. So hierarchy that they maintain is vertical. Assistant engineer to senior engineer to team lead, moves ahead to project owner, then goes to CTO. Okay. If assistant software engineer wants to uh, deploy a feature which he thinks is really cool and would solve the problem in a better way, he needs to get approvals from all of these people. And then the approval chain starts on the web mails. They start responding to it a couple of days, couple of weeks, just to know that it's not the right time to release that particular stuff. We don't want this approval chain to be that long. So one of the structural changes that should happen in our organization is to reduce the number of hierarchy. Okay, the best way to reduce the approval cycle is to automate that. How do you automate an approval cycle? You could branch it off. You could create your feature and simply show it. Okay, looking at a feature virtually and seeing the impact on screen with numbers, that this is how your system looked like and this is how it looks like now, that's more impacting than simply initiating a mail chain to say that, hey dude, I want to do this, which will change your system like this, like that, without having concrete proof. Okay, and to test it, you need to have a continuous integration in place, which would be branch specific. So your branch specificness is really important. So you should not be able to mess with the master branch right away. You still work in isolation and your system is able to be tested in isolation. And that should happen automatically because you want to expose it out to the world. What if your senior wants to check it at his VRs in evening and when you are not in office, right? We'll see how to do that. So here your SCM is actually source code management, also called as VCS or version control system. Okay, you could call it anything you want. We would be using a software called Git for that purpose. So it records all the changes to the documents that we are building, along with the history, along with the different versions. Okay. So the problems like who did this yesterday, look, why you committed this line, but how do we figure out the you part there? Who committed it? So there has to be a history. And the reason why he committed it, there needs to be a message that I'm committing this code because of these and these things, or this is the reason why I'm committing it. All right. That history and all the versioning is handled by SCM. We will see how Git works at it. What is the internal architecture of it, the way it stores the data, why is it good, comparing it with the other systems out there. I would be using Subversion for that. I think Subversion and Git are being used mostly, right? And most of you would be aware of one of the names. So we'll compare these two. There are other players in the market as well. Like CVS is there. CVS was there before, even in Subversion. And then there's Perforce, there's Mercurial, but I would be choosing the two leaders, Git and Subversion, for that purpose. Then comes in testing. You could use any testing strategies you want. For a Java project that we would be taking up during the demonstrations, JUnit could be used for unit testing. Then comes the integration testing. There are various different frameworks like Cucumber out there, which would be helping you do the job. Selenium, called SE, is also being used for GUI testing, where you don't want to be sitting in front of monitor clicking the buttons. It can automate that stuff for you. Okay, so continuous testing is something that we would be building in. Then comes continuous deployment, which can be broken down into two sections: continuous delivery and continuous deployment. What's the difference here? Let's say you're testing something. After it is tested robustly, you say that, okay, this particular piece of code or this particular bundle or package that I've released, the jar file or the war file or your binary, whatever you have created after your testing steps are done, it's reliable and you want to store it somewhere. Okay, you're releasing that zip or that war file or that piece of code. You want to name it that this is perfect, it was done on this and this particular time, the version is so and so. so that you could refer to it again. You don't have to go through the complete CI section or continuous integration and continuous testing steps again. Okay, so releasing your code out is done continuously. That's why we call it as continuous delivery. All right, it's not deployment. Once you have released the code, it doesn't mean that you will always deploy it. Okay, at every step we filter out things. We need to filter it out. Otherwise, what will happen? See, there are 500 developers in your company. Everyone commits at least 10 times a day, and it would be 5,000 changes. How many seconds are there in a day? 86,400 seconds. Okay, and out of those, that much time you are deploying 5,000 times a day. That means every couple of seconds your machine would be overloaded with some deployments. Although deployment can be done anytime, but I wouldn't recommend it to be done a lot. A lot means it wouldn't give your machine some breathing time. Now that breathing time is required for a lot of steps, a lot of things rather, to refresh the connections, to get the new connections done, to build the pool, to build the cache. If you're doing, or if you're taking care of all of these things and making sure that your machines are always in a warm state, they don't need to rebuild anything. Only in that case you can redeploy a lot of time as you want. Okay. So what do we do for preventing this? Simple strategy is to filter out things. Let's say 500 developers are committing a lot of times, 10 times a day, resulting in 5,000 commits. But 5,000 commits, if you tell Jenkins to pull commits only after 5 minutes, every 5 minutes it would be pulling the commits. So let's say in last 5 minutes I have received 10 commits. Yet another 5 minutes I would be receiving, let's say 15 commits. So Jenkins would be pulling 10 commits and 15 commits at a time. So that's the first level of filtering out, right? You're bundling commits together. Then you're testing them. You're testing them together. So maybe the tests pass, they fail, they do it on a complete block. All right. So your code happens to be bundled up. So once you generate a package out of it, that package is released somewhere, right? Now if you release the package, that package would be released multiple times a day. Now you could choose that I want to deploy once an hour. I want to deploy once every couple of minutes. Then you could choose the latest package which has been released out and then deploy it there. You can slow things down, but not at the level that you would be deploying once a week. Okay, not that. That's not advisable. Question from Hema: that what are commits? Commits are also called as check-ins. The code, when you're ready with the code on your machine and you want to share it with other people, okay, you want to push it out, that you are done with the code, you are confirmed that it is going to work, you want to share it with other people so that other people can work on the other sections of the product, right? The product is a shared entity, everyone else works on the same thing, so you want to share it. So how do you share it? Definitely not from your machine. You need to push it out. Okay, to push it out, you need to let other people know why you are pushing it out and what was the reason for it and who did it. Of course, you did it. So you do some operations. That operation is called as commit. Okay, so you commit to the code that I'm the one who is done with this particular feature for so and so reason. I would be sharing this with you. So it goes out to a particular machine. Okay, either it would be sitting locally, in that case you would be pushing it out. I'll talk about what that is, but for a non-bookish definition, committing is to finalize your code and move it to the closest repository. Repository as in the second machine which is there, the closest one. That's the committing for you. Question from Siddharth: is it possible for a CI system to build only selectively a single jar within a year based on which code has been modified? Yes, you can do that. Okay, you could specifically take in only the code that has been modified and then build stuff on top of it. It can be easily done the way you are doing it. You could have CI system use Maven for getting the dependencies. So create your project in smaller chunks and call all those chunks as dependencies. For building one of the microservices, you pull from those dependencies. So the code only for that particular section has changed. You don't need to rebuild all the dependencies again. Okay, you only pull them as and when required. So that can ease, like speed up a lot of stuff. You don't need to rebuild everything. Question from Nirpendra: that do we learn something about Ant and Maven? You'd be learning about Maven. but not a lot. This is not the part about learning a particular language and its build tools, but we would be touching upon that. So Siddharth, I'll have to look on that. Okay, it's again a language specific part, so I would not be drilling in deep into that. But I'll have a look. If I get past something, I'll get back to you. Cool. So that was SCM. The next part would be continuous integration, then testing, then deployment. So see, Git would be one that we are using, and this is just an overview of how it looks like. There is a local repository, there's a remote one. So I'll talk about what repositories mean, what is the working directory, what's the index, what is head, and what are the different pointers that we could use. But for now, we'll keep it simple. Okay. So in continuous integration, what happens? Your code is integrated continuously, as and when you check out, as and when you check in or you commit, the process starts. So if you have been paying attention closely, your continuous integration depends on your commits, and the complete pipeline is triggered whenever a commit happens. So your commits can actually be treated as triggering point for your pipeline. Once you trigger a pipeline, it's called a pipeline for a reason. You push in something and then you don't mess it up. It goes through the stages automatically, comes out of the another end. It doesn't leave the pipeline in between. Okay, it can only be stopped. It cannot leave the pipeline. So let's say your testing failed, your code would be stopped here. Okay, so what do? You don't divert the code from here. You again build it. You again fix the things right on your branches, and then again generate a trigger. That means again commit something, and it again passes through the pipeline. So pipeline would be acting as a sieve. Okay, as a filtering point. You make sure that the code is actually getting filtered through all the different stages and then getting past the pipeline, so that you ensure that the quality is always present there. Okay, so we would be using Jenkins. What does this Jenkins do for us? It handles automation. Okay, and it is just a framework without any of the features. All the features are provided by plugins. So these plugins would be helping us to check out the code, to get the code there, to build it, to test it, to push it out. So when I say pull the code or check out the code, it means that connect to a particular SCM system, validate yourself, authorize yourself, get the branch that you want to, get the code, download it. So all of these things can also be scripted, right? You could write a script for that. But since we are facing a generic problem, why not they use the solution which is already in the market? So Jenkins would be having a plugin which handles that part for us. And that script is a dynamic one. So you pass it some configuration and the script will behave according to that. Okay, so we use a plugin for that. So Jenkins would be allowing us to set up a plugin and do our job. That's what Jenkins does. It would only help us automate. And what would it automate? It would automate anything that we can do all by ourselves. Okay, if you cannot do it manually, it cannot be automated on Jenkins. Jenkins only automates firing the commands, right? It might look like it is sending an email for you, but you could also do it from the command line if you want. It might look like that it is taking the code from the branch on particular Git repository, but you could also do it from your command line. If you cannot fire Git command on the command line, you cannot automate anything on Jenkins which is related to Git. Pretty much straightforward, right? That's what. So if you cannot fire commands using Jenkins user on that particular machine on which Jenkins is running, it's not going to work on automated basis as well. Question from Eric, that one confusion, that commit would be done by many small modules in a full release package. Then deployment would be done when new full build or pack is generated after update or commit in each small module it contains. See, let's simplify it. Any stuff that you want to release is actually a snapshot of code in time, right? So in your SCM, whenever you want to release something, you need a build out of it. You need a package or whatever you generate as a deliverable for you. But it is a snapshot of something in time in SCM. After you add a commit, your snapshot would change. Okay. Your continuous integration makes sure that even a small change to the package, even a small change to that particular snapshot is always stable. That's what it ensures. And if your snapshot is always stable, you don't need to worry about whether the commit is coming in at what rate. Okay, even it comes 100 times a day, and if your snapshot is stable, you could deploy it 100 times a day. But for the reasons that I told you, that machines would not be able to cope up with all the intermediate stuff that it needs to do during the deployment, we would like to slow it down. Okay, bundling it up is not always a solution. Sometimes one individual change, one single line of code can also be pushed out to production. Think it is of as let's say a small fix. Someone coded something and he missed a line in just the login screen, so your login screen doesn't come up after deployment. You know that the problem is very small. It requires a quick fix. You just add a particular line and push it out. Okay, for that you don't need to worry about bundling everything and building all the small modules and then a package and then pushing it out. You do it really fast. Question from Srinivas. What are the other integration products available? You mean to say continuous integration systems or integration engines that are available in market? There would be Travis, there would be TeamCity, there would be Go, Jenkins. We are going to cover it up. Okay. There's another one called Fabricator, which has got its own engine internal. There are a lot of machines. There are a lot of systems out there. Okay. Question from Hema that can I perform server patching using Jenkins? It would be best done using any configuration management system. So you could use Puppet for that. That would be your best bet, not Jenkins. Jenkins is only a facilitator. Question from Anoop that build can be triggered from SCM or from the place where the test case is location like Confluence. There are multiple modes of triggering Jenkins. I'll talk about it in tomorrow's class. Okay, so you could trigger it from commit. You could also trigger it from external sources like Confluence. You could also trigger it from your scripts if you have a program to do that, or from a cron job, or schedule it on Jenkins itself after a couple of minutes. A lot of possibilities. Choose the one that suits you. Question from Nirpendra that how the code is built or packaged. Does Jenkins do it for us? Well, again, Jenkins is just a facilitator. So for packaging a code, if you want to fire something like mvn space package, because that's the target that you want to use, or and space build, if that's the one that package is good for you, Jenkins will do the same thing. It will fire the command maven space package for you. So it's not Jenkins that does it. You will have to configure everything all by yourself and make Jenkins do it for you. Okay. Question from Nagendra that in simple Jenkins is used to create a build from SCM. This build is what is tested. Yeah. I wouldn't say Jenkins is just used for building from SCM. It is used for integration. So it's just an automated engine, right? It can be used for multiple things, like pulling the code, building it, testing it, deploying it, okay, pushing it as a release, and then triggering a deployment on the production. People can also use Jenkins in production, although I really discourage doing that. So in simple, what you say would be yes, but it's not the whole part of story. Question from Sai Kumar, how about Electric Commander? Again, any tool that you use. Question from Siddharth that are you going to cover orchestration as well? No, unfortunately, because for orchestration you need APIs for infrastructure, and for APIs for infrastructure you really need to depend on cloud systems. So I would not be covering up orchestration here. If you want to automate virtual machines using Vagrant, it's totally up to you. Okay, that would be a good bet if you want to do it here on your laptop. Question from Srinivas that does Puppet support IBM AX operating systems? I think yes. A couple of friends of mine are using that, but I haven't used Puppet for that operating system yet. So see, it totally depends just on the client part. Okay, and I think there are clients for that operating system as well. Just have a look. Question from Hema that would you also cover Python basics in this class? Well, no, I would not. But there's a nice ebook if you would like to refer. Instead of referring the complete reference, which is a lot to take in for beginners, the ebook's name is Thinking Like a Computer Scientist in Python, and that's the name. That's just the long name. Thinking Like a Computer Scientist in Python. It should get you started, and just a couple of days, if you really practice, you should be good with Python. Yeah, thanks, Kumar. So Kumar has shared this URL for AIX support, and there you go, Srinivas. So you should be able to get through this link and help yourself out. So your Jenkins helps you in automating everything that you could do manually. Okay. On the testing front, you could use any testing framework that you have, but since it is a pipeline, it is triggered continuously using the commits. Hence the word continuously has been used multiple times all over the places. We would be using Selenium. We might also use JUnit. It depends on what kind of test cases we are going to run. We'll see that in tomorrow's class. Okay, test script can be written for multiple languages. Selenium helps you run it on multiple browsers at once. It's not a capability of Jenkins again. It's totally depending on which WebDriver you use. Okay, it has nothing to do with any CI/CD. It's totally your tester's job. If your tester says that we are just building the backend services, we don't need Selenium, it's totally fine. They use something else. Maybe you have Python code, so you wouldn't be using JUnit for that. You'd be using PyUnit for that. If you have PHP, you would be using PHP lint instead of any of the other drivers that we are talking of. It depends, right? So don't get stuck with the tools. That's again a word from me. Don't get stuck with the tools. Configuration management, we are going to cover up Puppet. Puppet would help us in setting up our machines. So if we kill the machine, you want to set it up again, you just bring it up and configure it again using the script that you have. So writing scripts, we are not going to write a script. Okay, we are just going to describe a state. We are going to tell Puppet or any configuration management machine engine works the same way. We tell it the end state. So we would be telling Puppet that, hey man, we need a machine with Apache installed on it, and the home page should look like this, and the directory should be like this, and I want a new user to be created, and I want it to be authenticated using this and this password. You need to describe it. Okay, so there would be a specific format for every configuration management engine. There is a special format that they follow. Puppet has got its own. Chef uses Ruby as description language. Ansible would be using YAML format files, and same with SaltStack. Puppet has got its own language that we would be talking of. I told you that the learning curve for Puppet was a little steeper, so you're taking up on that. Then when you have configuration management, your configuration may be for a container or maybe for a virtual machine. Depending on what you talk about, your continuous virtualization would take care of it. Okay, so continuous virtualization, here you would be working on virtual machines all the time. Plus, we would also be covering up containerization. So we will be deploying our stuff inside containers, not tomorrow, but later down the line. So we would be building one thing at a time, and all the stuff that we are building integrates with the other stuff that we are learning. Okay, so if we learn Git tomorrow, I would be reusing Git when I talk about Nagios. Okay, so it is going to be repeated multiple times. So don't worry about that. But just in case, I don't want you to be asking Git questions in Nagios class. Okay, in Docker, we would be talking about how do we spin the containers, what are they, what's the differentiating points between the virtual machine and the containers, why do we use it, okay, what the stack looks like, what are the points where we really lose on virtual machines or gain on containers, why we should be using it. I'm not totally in favor of containers nor in totally favor of virtual machine. It's the problem statement that describes what you should be using. Okay, and then comes the monitoring part. The monitoring part which is covered here in the class, it's not complete. Okay, when I say complete, it does not cover the application monitoring section of it. Although you could do that using a plugin, which we would be building for sure, but Nagios is not good at that. Okay, so use a tool which is good at the stuff that you want to do. If Jenkins doesn't work for you, scrub it off, use something else. If for application monitoring you think that New Relic is the good container, or if you log everything and put it into Elasticsearch, it would be a good choice for you, go with it. All right, Nagios has been around for long, so it's like a caveman's tool for doing the job, but it's really awesome at infrastructure level, and not a lot has been changed at the infrastructure level, right? We still have got the CPUs, we still have got the RAM, we still have got the disk. Since those things haven't changed, Nagios haven't changed for a lot of people. But on the application side, it's totally a different story. So use the tool that suits your requirement there. Question from Siddharth that instead of using Ubuntu server in VM, can we do the assignments by downloading and configuring the same tools for Windows? Yes, you can do that. But a lot of things would change when it comes to configuration because it is operating system specific. Things that work on Linux would not work on Windows. Jenkins, Git, testing, as well as Docker would work the same way on Windows. Other things like Nagios, Puppet, I would recommend you to still stick with Ubuntu if you want. Question from Vishal that for a basic project, what will help make us decide the configuration of a VM? I would not talk about the production. I would talk about the current state on your own machine when you need to be creating a lot of virtual machines. So see, um, server edition Ubuntu version takes no more than 150 MBs of RAM to execute, to run. Okay, so if you're low on resources, 300 MBs of RAM on server edition Ubuntu 14.04 is fine for any given day, any given machine, apart from Puppet Master. I'll let you know when you configure Puppet Master again that you should be having at least 1 GB of RAM. Or even if it is 512 for a couple of nodes, it's fine, but you'll have to configure it. I'll let you know where to do that. Apart from that, 300 MBs is a cool deal. In production, the more you have, the better, right? Depending on the services that you have. I wouldn't recommend having a lot of RAM, let's say 4 GB or 8 GB RAM for Nginx web server running there. Okay, so you'll have to benchmark it. Benchmarking and load testing, stress testing is one of the biggest challenges that a DevOps engineer has to take in. It gives you a very crucial statistics about how things perform in production and how much cost you could literally save. It's not that you simply put in one service per machine and thinking that maybe M3 instances are rigid and robust enough, you deploy everything on that. It's not like that. Okay. For now, 300 MBs is fine. On production, you need to benchmark it and then see how much footprint you really need under load. Okay, that's the another reason why we use containers, because we are not sure. Okay, I'll talk about that when we talk about Docker. Continuous monitoring, it would be Nagios for us. Nagios, what it does is it takes input from one side of the one side of your infrastructure and passes it out to the server end where it generates the report from it. And then it would be notifying us using the various different means. We'll talk about that later. So now that you know various different tools and the location that they fit in, okay, that's your end goal. Okay, so this is your pipeline would be looking like. Theoretically, practically it would be a lot different. I'll talk about that in next couple of slides. So here, some questions. I didn't talk about Jenkins and Git much on the technical front because there are classes in which we would be talking about it in more detail. So by the way, just for curiosity, Jenkins is written in Java. It was initially created for Java project, and when people thought that, okay, we really created a nice tool and nice solution, let's be generous and give it out to community. So these generous people have released their solutions out as open source, and there are a lot many people who like to do that. All the Apache guys, right? Elk guys, they have released solutions out to public where we can use it and we can contribute it back. So it was written in Java. It was made for Java. Then it became very generous, and people started to contribute very generic solutions to Jenkins, which made it to be adaptable to other languages. Now in the Git repository, it doesn't make more sense right now. The answer is A. I'll tell you why it is A, how it is structured, what is a bare repository, what is a workspace, how it looks like, what are the different folder structures and all that stuff. But just get past this slide. It's A for first, and Jenkins is developed in Java. Can anybody answer this question for me? When should automation testing be used? It's a common sense question. Let's see. Anything that relates to culture, it's common sense. Okay, we see a problem, we adapt ourselves. If we don't, we lose. And question number 4 is about Puppet Master contains what? Well, scrub it off. It's manifests, by the way. I'll talk about that in detail, about what are manifests, what are reports, how do we build it, what are different modules that we could use. But I don't want to get ahead of myself, because if I tell you what's .git, then you'll ask me 1,000 more questions. But instead of doing that, let's see how it looks like, and then we can definitely come back to questions. Right. Question 5. Containers running on single machine all share same OS kernel and start instantly and make more use of RAM, more efficient use of RAM. The answer is yes. Okay, that's the biggest differentiator between your virtual machine and the reason why people are using containers. It changes the whole idea about resource allocation. When you create a virtual machine, you are actually pessimistic about your resource allocation. Uh, let's take an example of AWS. You want a virtual machine from AWS, and you say that I want a virtual machine because I want to run a web server. AWS is very skeptical about things, so AWS would say, I don't care what you run inside of it. Here you go, you take 2 GB of RAM and 2x computational power and pay me this amount of money. I don't care how much of that 2 GB RAM you are going to use. That's a pessimistic approach, right? Because they don't care. We care. Even if we are using 1% of the RAM, we are paying for 100% of it. Bad idea, right? If you are running a bigger company like Google or Facebook and you are wasting 99% of your resources like that because AWS is just pessimistic in its resource allocation, it wouldn't work for you, would it? No. So we make more sense of things. So we say, let's do one thing. I don't know that I would be running one service per machine. And even if I do it for a reason. I do it because I want to maintain isolation between my services. If I could fix that isolation problem, okay, if I could prevent one of the process actually killing or interfering with the other process on my own machine, I could easily fit in as many services I want, correct? The same way you are running over 100 processes on your operating system right now without worrying about any of the process actually eating up your memory. Are you worried about it? You're not. Can you spin up another 100 processes on your laptop and not worry about it? Yeah, very optimistic about it. You could do that, right? Right now, your operating system might be operating at 20% utilization, 30% utilization. That means you're wasting 80 to 70% of it. If you could fit in some more processes on it, you would be making very close to 80% and optimum use of your resources. That's the way Google and Facebook would think. The companies at that level would think, because they operate their own data centers. They don't hire cloud services from someone else. So for that, they have moved into container scheme. So they say, instead of running one service inside one virtual machine, let's run multiple containers and not worry about wasting a lot of resources. So I could make the optimum use of it, optimum use of my resources, and push in as many services as I can on one single machine until it reaches some optimal level. Optimum level could be 80% or 85, 90%, whatever you choose for infrastructure. Don't worry if it doesn't make sense to you right now. Okay, I'll do this discussion again just for the sake of questions. The answer is true here. And what are the objects in Nagios? Well, again, it would be kept for the last class. It's the elements involved in monitoring. Okay, they don't change. They don't literally change. It's very same old architecture, even in hardware part, right? Same disks, same CPUs, same RAM, capacities and speed would be increased, but it is pretty much the same. You wouldn't find a computer without RAM, right? Cool. Now look at this from a case study perspective. So your ecosystem would look like this. We would be learning things over next 7 days, and at the last we would be combining everything into one, like revising everything that we have learned so far. Although during the other days as well, I will be integrating the new stuff with the older one. Okay, so slowly and steadily we will move from left to right as code moves. So your code moves horizontally, it never moves up in the hierarchies. All right, let's look at what our use case would look like. So in module 2 we are learning about Git and Jenkins. A lot of questions about Git, why, how it looks, where to configure stuff, what are hooks, what are not, Git commands, branching strategies, merging, why do we use it, how do we do that, what is stacking, what is unstacking stuff. Okay, I recommend you to go through the slides for tomorrow's class before you arrive. Then we'll be talking about Jenkins. What is CI? What is Jenkins? How do we create jobs? How do we set up plugins? What are users? How do we create them? How do we allocate roles? How do we set up the security? How not to allow anyone to mess up with Jenkins? Okay, authentication, all that stuff. How to integrate that with existing Git. All right. Now that we are learning a new tool, we will try to integrate it with the previous one. And that's how we learn more about the new tool as well as the older tool. That's how I like to take things forward. Module 3 would be talking more about Jenkins. So Maven, building, creating of test jobs, releasing stuff, deploying stuff, notification systems, all right, all of that. Plus we will also have some code with us which will allow us to get our code from the initial level, that means SCM part, through Jenkins, testing, and then releasing and deploying. So we'll talk about the class project as well. Okay, that is going to be our end goal of total 8 modules. I'll talk about what the test case would look like in coming slides. Module 4 is about Docker. So people who have been asking about containerization, here is the Docker thing. So in Docker, we would be talking about very frequently used commands, the use cases of it, why do we use it in the first place, the differentiation between that, how does virtualization help, what are hypervisors, why is it difficult to run Docker on Windows, and why is it so that Windows supports Docker containerization in cloud and not here. There are a lot of reasons behind it. So we'll talk about that. I'll go into details of it. Conceptually, it matters a lot to hear the talk. So if someone of you is actually scheduling to miss a couple of classes, please don't. And if you are also thinking about not attending right now and revisiting the videos later on, I wouldn't recommend doing that as well. So see, it is a 3 hours class. If you go through the video, it is going to be 3 hours of again watching the videos, and it's not going to be 3 hours, it's going to be more than that. Pausing, running, and doing your stuff in between. Don't do that. Be in the class. Okay, take down notes, concentrate on what is important, because there are a lot of concepts that I've been talking which is not on slides. It's totally out of experience that comes. You could take it down, jot it down, and then do all of your research stuff on Google. You never need to come back and waste your another 3 hours on videos. Please don't do that. How do we distribute the image so that it can be reusable? And one of the interesting things about Docker, well, Docker is not a container. Docker is just a wrapper on top of containers. So container technology is different. I'll talk about that, what it is. And there are different players in market apart from Docker who are providing this container technology. But we know about Docker because it's famous. Yeah, so we will be talking about containers a lot. And interesting fact about Docker is that it provides us a layered architecture where we could actually have versioning of our operating system. You know, versioning of code, right? You commit something, you get a new commit ID, or you get a new revision ID. You can version it. You can say that, okay, my version is so and so. You can also do that with operating system, and that's interesting. If you install a package, Docker would help you understand how many files changed, how many files were added, deleted, modified. What are the changes that you're actually going to commit back? So you could commit an operating system on top of operating system. It can seem fascinating, right? I'll talk about that in detail. So class 1 is all about letting you know what's coming ahead. If you are overwhelmed by all of these things, I'm sorry for that, but it only would prepare you to look into future and be prepared for the next classes. Docker would be distributed over next 2 classes, for module 4 and module 5, total of 6 hours that we would be spending on it, detailing from image creation to automating everything, to recreating and snapshotting images, to release the containers out, and to deploy it onto the end machines. Some of the sections which we are going to deliver before configuration management are going to be manual. Okay, so we would be doing things at a very crude level. It's always good to know things at the crude level, because when you automate them, you will see the difference, what automation brings out of that. It is very easy to create a Google account and then simply complain that email is not working. But it is even more interesting to create a Google account sitting backside from the CLI. Okay, that's the interesting part. Even if you even in your company, when you deploy something, so running configuration management system or getting stuff done via OVA images, it's fairly simple because everything is configured there. But when you literally create a machine right from scratch, set up the keys, create the user accounts, get the packages there, resolve the dependencies, then configure your code, make sure that it works, build the firewalls, and harden your server. All of these things, when you do it manually first, and then you automate it. Okay, for sure, because anyone who has automated it must have done the things manually first time, right? And I want to teach you the very first ground level stuff about it. That's what we are going to do. Module 6 and 7 would be talking about Puppet in detail. So if not extending Puppet, we would be taking it up to the intermediate level where we would be understanding what Puppet is, or any other configuration management system is, what it does at the ground level, where to find the help. For any other tool also, I would be doing the same, because finding help is the most important part of our life. Where to find it, how to use it, how to read it, how to make use of it. It's really important. Asking questions would not always help you out because it takes time to first get the right question, then ask it to the right person. Okay. What the architecture looks like, what are the terminologies, how the language looks like, how is it different from other tools. It's module 6. And then in module 7, we'll make sure that every architecture piece that we have built so far, we will be converting that to Puppet. Okay. So we would be using the modules, we would be using the templates to configure our machine, to push the files there, to make sure that your end machine, let's say you are deploying it on some web server, so it has got Nagios, it has got Nginx, it has got HA proxy configuration on top of it. All right, it would be that. So you would be using and implementing Puppet in module 7. Also learning about some Puppet internals. Okay, the Puppet language basically. And we do have a problem statement that we would be taking up. I'll talk about this problem statement in a couple of minutes. There are a couple of questions here. Hema is asking a question that, can I ask Ansible related questions after this class? Yeah, please do so. Question from Arvind, what is the main difference, advantages between Docker and Vagrant? It's totally different. See, Vagrant works with virtual machines. So if you're working with virtual machines, Vagrant is the tool that you would be using for automating stuff. Okay. And for Docker, it is a container management system. So it's totally different. I'll talk about that in the containers class, module 4. But that should give you an idea. Virtual machines versus containers. It's something that you compare like apples versus oranges. You cannot do that. Question from Dipendra that, does Jenkins package code with Docker? See, Jenkins can do anything you can do manually. Straightforward answer is yes. So you can have a Docker file that will get your code and build an image out of it, and then you could deploy the image rather than deploying your code. So it's always a good practice, and Jenkins can help you do that. Question from Hema that, I have got Ubuntu 12.04 installed on 2 VMs. Would it work? It would work. I would recommend you to use the latest one, 14.04. If you want, you could also jump to 16 version of Ubuntu, but make sure that it is server edition. I don't want any colorful screens elsewhere because it takes a lot of resources. Plus, if you really want to be bearing with me, I want your life to be black and white. Hence, from now onwards for next eight sessions, black and white screens, no colorful screens whatsoever, because there's a reason behind it. The reason is I want you guys to imagine, because when you talk about cloud infrastructure and architectures and virtual machines and all that stuff, you really need to be fiddling with your imagination. That that there's one machine sitting there right there. You cannot see that, right? You just need to imagine it, and there needs to be just black and white screen. The way you hop, the way you jump from boxes to boxes, the way you copy the keys over, I want you guys to have a feel of it. So Ubuntu Server Edition 14.04 on as a VM, okay, that would be great. So it's 10:25 here on my clock. I would be getting back in exactly 10 minutes, which would be 10:35. Then we'll continue with the remaining slides. Question here from Vishal, a quick one. Will we be getting the list of tools required so that I can be prepared for upcoming modules? Yes, why not? You have already got the list, right? Right on the slides. So you could do that. Plus, working with me is only recommended if you could really work that fast, okay? And you already have got an idea of what's going to be happening. Otherwise, you will lose a track of things. So it's always good to take notes and then do it after the class. So you should always be prepared, right? Downloading a tool is not a big deal. It should be very quick. Question from Eric, any good book you recommend to know details of operating system concepts like processes, resource, memory leakage and all that stuff? The old favorite called Operating System Concepts. You could Google it out. It's the book that is taught to college guys, early graduation stuff. Okay, no one talks about it unless and until you're really worried about that part. Okay, the whole idea about being a DevOps engineer is that people take you for granted for these kind of concepts. So you need to be prepared. Good question that you have picked it up. The book is called Operating System Concepts. It will talk about everything along with the algorithms that are being used. Question from Jitendra, will we be getting the PPT? Yes, go to the LMS and PPT would be shared with you. It's shared for everyone, right? You should be able to get it. Question from Dinesh, will you be using VM in tomorrow's class? Yes, pretty much. I would be using it. About the problem statement, so what we are going to target with the continuous integration, continuous deployment pipeline that we are going to build. What is this pipeline solving? What problem are we looking forward to? So this problem is that we have got a website which we are hosting. Okay, so this problem is specific here for Edureka's use case. Thousands of learners, 6,000 classes in parallel, and they have got a large audience which needs to be, which is actually spread across 70 countries. So it is global, right? We need to be operational 24/7. I cannot say that we would be down for our maintenance for, let's say, 2 hours, 4 hours. It doesn't work that way. It could be night for me, but it could be a daytime for a couple of other countries, right? We cannot do that. That's not an option. So they have a new homepage which runs on Tomcat, which fits properly with our Java use case. Okay, they want to launch it, and they want to expose it only to people who are in US. Okay, so there are various different problems that needs to be solved. Very first, 24/7 uptime, and next thing is that we have to support a large number of people. That means we should be able to scale up as well as scale down, because these people would be available only around weekends. Okay, large population would be only around weekends. Now, like we are visiting Edureka's website right now, during the weekdays we would not be doing it, and it would be only exposed to a couple of people from US region, not from India, not from any other continent. They want it to be exposed only to the US guys. So these things, how would we able to serve it? Now we would be building a CI/CD pipeline for that. Okay, and that is going to be our end goal. Other concepts which are not on slides, and we would be covering it, which definitely should be there. We are going to talk about scalability. We are going to talk about high availability. We are going to talk about load balancing and load balancing types. Okay, we would be talking about availability zones, subnets, clusters. Okay, we would also be talking about monitoring between various different regions and availability zones. So we'll talk about that as and when required during the tools. When we pick up the tools, we'll be talking about these things. But if I skip on a couple of these points, because these are something that I would like to take up whenever we got time between the slides, take it down and ask me questions whenever you would. Okay. Also come prepared with a couple of articles. Let's say there are a couple of websites that you should be looking at. DevOps.com is one such. There is another one called DevOps Guy. There is Agile.com, which would help you with some more information on DevOps and all that stuff. These are the cool websites. Okay, so you should read them. Actually, subscribe to them as a feed, so that you are never lagging behind with the data that you have. So these things, what they are doing is they are configuring everything manually here in the problem statement, and they want us to automate that. Okay, shell scripts are not working much fine, because shell scripts need to be triggered on all the machines. There needs to be a triggering point. Plus, if something fails in shell script, we cannot revert it. If you fire a command called hello world, can you revert it back? No, right? Anything that you fire on CLI cannot be reverted back unless and until you know which points it impacted. So you need a system to do that. And that's the reason why we are going to use configuration management. We are going to use Git for pushing the code out. Continuous integration would be done using Jenkins. Deployment would be done using Docker on containers in the machine. Okay, these machines, machine 1, machine 2, machine 3 are all Ubuntu machines. Here, if you see, multiple services are being overlapped on one single machine. In ideal world, in production, you would never do that. Okay, you would never have multiple machines sharing responsibilities. It is always a one responsibility model. So one machine would be responsible for one single aspect or one single service. So your database machine would never run web server on top of it. So Jenkins would not share responsibilities with Puppet Master. You need to be able to isolate that. Here it is the case because we have got less number of machines. We need everyone to be on the same page and people doing stuff along with us. So if you have a liberty of creating a lot more boxes, please go forward and do it. So create a Puppet Master on yet another machine, Jenkins on another box, Jenkins agent on another one. Deployment would be happening on yet another box. Okay, your production machines would be at least 3 2 servers behind a load balancer. So that kind of scenario. So we'll talk about that. As and when required, I'll also tell you when to overlap the machines and when not to do it. It's totally up to you. Depends on how much resources you got. We'll be talking about Selenium and testing. We'll be using the test boxes for that purpose. Okay, so we'll be doing a lot of stuff. And the setup would look like this, similar to this, but we will definitely scale it up. Because when I would be talking about scalability, I would also be talking about high availability, imparting redundancy in your infrastructure so that you wouldn't be worrying about if the machine goes down, what happens. That question has to be built, that solution has to be built right from the architecting phase, initial phase itself. Okay, if you think about it later on, then you would be going through a lot of pains. If you want to check it out, read a book called Phoenix Project. It has got an awesome explanation about the use cases, the case studies, and the way people adopt DevOps, the way they changed it. Okay, it's a nice book to read. Question from Vishal that will we be learning how machines communicate with each other for services they run? Yes, we'll be learning that. Of course, not on the slides again. Park this question when I will be talking about deployments. Okay, when we bring up any of the machine, I will also show you how to create passwordless authentication, because that's important when you talk about automation. In automation, we try to remove any human intervention. So things like entering a password, typing yes or no during installations, all those things are totally ruled out. So we need to find a way to do that. Okay, so learning how machines communicate over IPs, over the IP stack which is there, what are the different protocols that they use, when to use UDP, when not to use UDP, how do we do health checks at layer 7, layer 4, what are the differences between both of them, how do we configure our load balancer to do that for us, all this stuff. Okay, so that would be coming next. Between this, of course, between the slides. So every class is different, right? Depending on the kind of audience, your interaction level, your eagerness to learn. So it's totally up to you how much you dig into, right? I would be shelling out the knowledge as much as I can. Question from Hema that can we install Vagrant on Ubuntu? Yeah, why not? You could do that. You could install Vagrant on Ubuntu and ask Vagrant to spin up another virtual machine which will have Ubuntu inside of it. Yeah, why not? You could do that. We would be creating feedback loops as well. The whole idea of creating feedback loops is to have insight into what CI/CD is doing, what your bots are doing, and how they are performing like. Your feedback loops should always be targeted on being shorter, but at the same time more amplified. What does it mean? It means that shorter means you should be able to get the results back soon. It doesn't mean that I'm committing right now and I'm still waiting whether the tests are failing or not. I don't know. After a couple of hours, I get to know that the deployment failed. The whole time I was just waiting and thinking about what's happening with my code. That should not be happening. Okay, we should get the response out as soon as possible. So that's shorter cycle. And amplified as in it should give us actionable items. Instead of telling me that the deployment failed and leaving me wondering what happened, my system should be smart enough to tell me that, buddy, this particular line is missing this particular semicolon. You go and fix it. That's actionable. So getting actionable items out is better than simply getting notified. Sending the notification is good. Sending a lot of notification is really, really bad. People tend to overlook it. If you get notification for every single commit that is happening, or every single deployment that is happening on your production, or every warning that is being generated on production, people generally tend to overlook it. And at some times when a real error is happening, they simply think that it is a normal thing and they simply don't check the notifications. We don't want that to be happening. Okay, so you need to filter out what is important, what is not. If it is not, should we send a notification for it, or should we handle it as a part of our runbook? Can the system self-heal? The system should be self-healing. Okay, only reason why we use configuration management, okay, making it redundant, making it recurring, making it recreatable, it's totally fine. But when you assist that with runbook with some smart AI capabilities, I wouldn't call it as AI, but it's simply a do this, do that kind of if else statement that we build. But it's important. When we do that, we complement it with this capability, runbook capability. then your configuration management system can create a system which can be self-healing. So if you lose a machine, your configuration management system will be automatically triggered and you will get that machine back completely configured back in cluster and running. That prevents a lot of 2 a.m., 3 a.m. calls for ops guys. Okay, and they would be more than happy to do this. So a DevOps guy never receives calls in 2 a.m. or 3 a.m. in the morning. If he does, that means his DevOps setup is not good enough. I never got these kind of things in my career. So when we build it, we sleep very soundly. We know that if something fails, it is going to be self-healing. We don't need to be worrying about it. We will check the logs tomorrow morning and probably find a root cause of that, what happened, and try to figure it out and try to fix it so that it doesn't happen again. Right? That's the whole idea, how you deal with this problem. How do you trigger it? Monitoring. So monitoring has to be there. We need to trigger things using the monitoring. How does monitoring trigger it? See, monitoring would only get you logs, generate some real-time snapshots for you. You need to analyze it. And there needs to be another server which would be analyzing the things continuously. At the same time, it will also check the patterns. You know, machine learning, some people do deploy machine learning for the same reason, for just getting notified. If you want to do that, AWS has got nice machine learning capabilities, streaming capabilities, and queuing capabilities with that. You could use it, or you could create one all by yourself. There are some paid tools as well out there which will run on top of your storage systems like Elk or Splunk and generate notifications for you. Okay, so you could do that. We would be using Nagios for that. It's not, again, I would repeat it, it's not a great tool for analytics. It's only for monitoring purposes. There's a big difference between analytics and monitoring. Okay, so you need to have a tool that will help you do the things the right way. Question from Dinesh, that Splunk can also be used for monitoring. Yes, it can be used for monitoring, but you will have to make sense of what data comes into Splunk. Okay, Splunk has got a dashboard on which you could query the data. Nagios has got a dashboard in which it knows what data is coming in. It would make sense of it automatically. In Splunk, you need to create dashboards for yourself. That's only the overhead, but otherwise you could use it. Question from Nikhil, can you please suggest any free version control tool? I checked GitHub is not free. Is there a difference between Git and GitHub? Okay, I'll come to your question, just park it. Question from Srinivas, what is the scripting language we are going to use in this session? We are not going to use any scripting language. We are just going to use the code which is written in Java for demonstration purposes. So I'll show you how the check-ins work, how the code flows, how do we bundle it, how do we deploy it. That would be taken care of. Scripting language, if you want to learn, if you don't know any, you should start with Python. If you're interested in knowing shell scripting for basics, there's a nice tutorial. It's a one-page tutorial. Just hold on. I'll find one for you. I'll share the link. Knowing a good resource always helps because there are a lot of resources on the internet, right? Every person, every author would describe things according to their own understanding. Okay, and of all that I've found, this one for shell is really easy for beginners, and the ebook that I've told you for Python would really help you out. So I've shared the URL for Unix as in Linux scripting. Okay, another question here from Srinivas, that right now working on Ruby and Ansible. Yeah, no problem. You could start anywhere you want. If you are already working on Ruby, then Chef would be really easy for you if you want to get started. I've shared the URL on your chat boxes, so you must have received a message from me. Cool. So talking about these questions, if you are really attentive right now, head and git contains. Okay, forget about it. Another one, the tool in which virtual images are created for maintaining uptime of the environment is. Can anybody guess this? Question number 2. Okay, talking about images a lot, right? I was referring to Docker. Cool. Thanks for that. Next question. In our use case, continuous testing is done using what? On the slides, you have been, I've been referring to a name. Okay, so that's the answer. Another one is Puppet is, okay, I'll make this easy. This is a master agent, also called as client-slave kind of architecture. Okay, that's a server. There are a lot of clients. I told you that this kind of architecture is really helpful when you want to create scalable systems. Does it mean that Ansible is not scalable? It is readily scalable. Um, you could have as many kind of parallel connections as you want, but the number of ports can be a limitation somewhere, and managing the machines in that way needs a lot of network bandwidth as well. So it depends on what you need to do and how big the infrastructure is. So if you ask me blindly which one I should use, I would tell you that if you are using less than 100 machines, 200 machines, it's fair enough to use Ansible. If it is more than 500 boxes, use anyone, Puppet or Chef, that you like. Okay, even SaltStack would fit in that case. So in this module, what we have talked of, why, how, why and how DevOps is, right? And also what DevOps actually is. We have talked about CI/CD, the pipeline. I told you about continuous delivery. I also differentiate between continuous delivery and continuous deployment. I helped you understand how the ecosystem or the different modules are distributed and what we're going to cover in which particular module, and the use case, the end problem that we are trying to solve, along with the pipeline. So here, the pipelines are different. Let's say in tomorrow's class, we will see what the pipeline looks like. Why is it called a pipeline? What are jobs? How do we structure them? How do we trigger them? And what particular pipeline with how many stages are we going to build? So our pipeline would be having almost 8-9 stages. The one that we have seen during the class, it roughly has 4 or 5 stages. It depends, okay? So it depends on the problem statement. Question from Eric. The question is, what is the difference between continuous delivery and continuous deployment? Okay, see, when you have a deployable and you store it somewhere, you deliver it, right? That's the end product of your continuous integration. The way you store it after continuous testing, we call it as continuous delivery. You deliver something out. Whether or not you deploy it, it's a different part. Okay, you have delivered the end product, and that's called continuous delivery. When you create Docker images from your continuous integration, after your testing is done, that part I would be calling as continuous delivery. Once you deliver it, then you decide on whether or not to deploy. Okay, so from those artifacts, we choose the one, then we deploy it continuously out to production. If that is happening, it's called continuous deployment. I hope that answers the question. Question from Dinesh. You mentioned Agile and DevOps has to go hand in hand. Why is that? Well, see, I told you that Agile would be coming with its own problems. You need to keep your software always in a deployable state. Okay, Agile helps you to deploy your product in small chunks, and every chunk can then be testified by your client. Okay, for testifying it from the client, you need to deploy it. So there are problems of its own. You need to continuously test, continuously release, continuously deploy, continuously throw it out to the client, probably just a small chunk of people, not all of them. So you need to do this repetitively. That's the reason why you need DevOps. So DevOps would help you fix these things that Agile is creating as its byproduct. Okay, that's the reason why we call DevOps as complementary part of Agile. Question from Mahesh, where can I get Ubuntu image and installation procedure? Okay, Google it out. You can type in download Ubuntu. You can download Ubuntu server, okay? And on the Ubuntu official web page, you should be able to get the download link for an ISO file. Okay, if it is not an ISO file, if it is a torrent, then you will have to download torrent. There is an option for ISO again. You'll have to check. So once you get it down, you will have to Google something like set up VM with ISO VirtualBox. Set up VM with ISO VirtualBox. If you type in this, you will get complete steps on how to load the ISO, how to create the VM, and all that stuff. Okay. Question from Kumar: that do I need to submit screenshots as part of module 1 assignment? Yes, please do that. Question from Eric: how application communicate? Is application stack over UDP TCP? I need to learn it with references Linux OS. You don't need to learn anything new right now. At our level, we would be communicating over TCP. But when we talk about monitoring, I'll also help you understand why UDP would be preferred in a couple of case studies or scenarios. When we monitor our infrastructure, that can be done at 2 different levels in reference to your OSI stack, okay, at application level as well as at the network level. So there are 2 different layers that we need to work on. Another one is from Nikhil. Yes, Nikhil, I've unmuted you. I see your hand raised. Do you have a query?
Uh, yeah, hi Ashish.
Hi.
Uh, yeah, I just have a query, but I don't think so that is related to this DevOps. But I have one VPN on which my application is running. So I need to go for high availability. So what is the best possible solution or use case like you can suggest here? If I need to go
High
for high,
availability.
yeah.
What is the service?
The service is it's the cab service, cab application, cab booking.
Okay. So see, for there's one word answer to all of these things, high availability or scalability. The answer is redundancy. You need to add redundancy to your application. Okay. That's how you build high availability, because if one dies, you should still be able to serve your customers, right? That's the whole point of it. To
Correct.
architect that, you need to have a load balancer which would be pointing to various different web servers in the backend. Now, I'm not sure if there is sessions required or not. If there are some sessions required on it, you will have to push that sessions out from the web servers to some central storage so that web servers can share the session. Now, load balancer would be forwarding the data to these web servers. Now, about really core level high availability concepts, you have made your web servers highly available, but what about the load balancer? If load balancer dies, then web servers
Correct.
would not do any good, right? So your
Correct.
load balancer has to be highly available. So this can be done using setting up at least two load balancers which will share the same IP address. So one of the machines would always be having a different IP address first. Actually, both of them would be having IP address differently, right? A and B. So if A
Okay.
is your primary and A dies for some reason, then B should be able to figure it out. And as soon as it figures out, that means A is not working, it is not in network, it can automatically take the IP address of A and run the connections through it. That's how it is done at failover mechanism. Okay.
So like,
Or
uh,
you use ELB.
so actually, I was just finding, the tools for the with the minimum cost or the freeware tools. Can we achieve this or no?
Uh, Tools are free, but the cost of machines isn't free, right? Machines would be actually at a
No,
cost.
if I procure two VPS, can I do the same setup that you are talking about with the free tools or minimum budget?
Yes, you can do so, but you need at least three, not two.
Okay, so if I go over three, can you help with the only with the name of the tools? I will R&D on that tools.
Yep. HA proxy is for load balancer.
Okay, I will just write it down.
Yep. HA proxy,
Yeah, that's a proxy. Okay.
right? And anything else that you're already using. HA proxy is only used for load balancers. Everything else you already know. Your web servers. And since there are three machines, if you want to store the sessions, I guess you are already using database. So push the sessions to database. That should work at your level.
Okay, that to sync the MySQL database all over three VPS.
Yes. So database would not be on the VPS, is it? Is it still on the VPS?
Yeah, yeah.
Or it is okay. If your
No,
database is on the VPS.
yeah, sorry to interrupt. I have the whole application in single VPS.
Okay. So very first thing is that you need to break it down. If you need it to be highly available, because see, database copies, only one can be primary. Other ones are going to be read-only copies, right?
Correct.
If your
Yeah.
primary dies, then your high availability goes out of window. Doesn't work. So what we
Okay.
do is we break it down. Databases is a separate concern, and it has to be
Mhm.
handled using separate set of machines. And your
Okay.
web servers would be a separate set of machines, and your LB would be a separate set of machines. So we chunk it down in various different components, and we then think about high availability of a particular component. So database high availability would be only when you keep three database instances, one primary, one backup, and another one to be a DR side. Another one, then your web servers would be at least two in number, and two load balancers. So a total of how many
Six,
machines? You say, yeah,
three to seven
seven
machines.
machines.
So seven machines I need to procure and then go for HA proxy like setup.
Or even easier, at the level that you're working, don't worry about high availability all by yourself. Um,
Okay.
if you want to use some cloud provider services, use that, like platform as a service, or use infrastructure as a service from AWS or any other cloud provider. What they would provide
Okay.
you is a database which is totally
Okay.
managed, so you don't need to worry about high
Okay.
availability of your database.
Okay.
Only thing that you need to worry about is your web server. So you could create two web servers, so two machines you would be needing. Another service that cloud service provider will provide you is with a load balancer, which is totally managed. So you don't
Okay.
have to worry about failovers and those kind of scenarios. You will have a totally reliable load balancer. So you'd be charged only for your machines plus the data that you pass through your load balancer and the data that you store in the database. So it should be cheap. It should come in cheap.
Okay. But they charge hourly basis, right? And I think that are costly. Like, anyways, that calculation I need to do at my end. Thank you.
Yes, you should. And that would be cheap if you use low-end machines. At the traffic that you are serving, you are the best person who would be able to figure out how big your machine is. If you use the free tier resources, okay,
Uh-huh.
in free tier resources, you would not be charged. If you use, let's say, T2 micro instance for your web servers, you would not be charged money for that,
But
unless and until
that
you spin up.
that is free only for a year, right? Like it's
It is free only for a couple of 100 hours every month. So it's
okay.
like if you use two virtual machines, it would be half of it. Okay, one virtual machine can be executed free for a month. So if you run two, you would be running out of that particular allotment within half a month, and it's not much. It's cheap. You do the math, you will see.
Thank you.
Yep, you're welcome. I hope everyone has got the LMS access. You must have received your email ID and password. If not, you'll have to sign up. Okay, just log in. It would present you with a screen which would look like this. If you move to courses, my courses. For you, it would be this page. For me, it's slightly different. So once you are on this page, depending on how many courses you have registered for, you will see those courses there. Okay. So I'm right now clicking on DevOps certification training, and there would be 3 sections for it: getting started, pre-recorded classes, and course content. You must have already gone through course content. If not, I really suggest you do that. Um, do that in detail. At least skim through the slides which are supposed to be covered in the next session. It's very important. All right. Then on the getting started section, I think we have two parts here. One is just for you. The second one, first one, getting started with DevOps. It would also provide you with a link for downloading the VM. Right now, it's a little bit messed up. I'll get it fixed. Pre-recorded classes would be having recorded sessions from the previous classes. So if you want to prepare yourself before coming to the class, which I would recommend, please do it, because you should be having a fair idea of what's going to be delivered. Plus, you can point your questions straight towards the problem. Otherwise, people generally don't tend to ask questions and they tend to park it a lot. 4 or 5 days later, they would come back to me asking questions from the module 1, uh, which is not a problem at all, but I would recommend you to keep with the flow. If you don't, you will miss out on a lot of stuff. Okay, and what is being delivered in the class apart from the slides totally depends on you. The more depth you want to cover, I would be help you out. I will be here to help you out on that. Okay, it depends on the audience as well. More you interact, more you ask questions, I know that, okay, whatever is delivered is being assimilated, it's been absorbed properly, and I can go to the depth. Okay, I can move to the next level there. Now, in the course content, you will also find recordings for the current class. Right now, this is the first class. You wouldn't be having any recordings here, but there would be a link appearing here in this course content as well, which will show you your current recording. Today's recording would be uploaded in a matter of 2 to 3 hours. You can go and check it out. You will also get a notification back. Okay, so here we have pretty much everything. For people who would like to get in touch after the classes, there's a nice section here. We call it as support. Okay, at the top right, okay, there's a button called support. You click on it, it will allow you to send a question. Let's say you're working on Jenkins, you're stuck somewhere, you're not able to find a solution on the internet as well. So whenever you're trying to find a solution, you should be at least asking your colleagues first. Even before that, if you're a good Googler, you should be when you're joining any of the technical streams. search out for the solution. If you don't get it there and you need an expert advice, always come back to this section. But I would recommend do some research yourself first. If it is just a stupid question, stupid as in it's a really simple thing like how to install Jenkins, and you keep on asking about it, nagging about it in 4 or 5 classes, that means you are not really helping yourself. Okay, that's a bad thing. You should be helping yourself first. Select the course. Okay, select the category of the question. There are a lot of them, and then type in your discussion or a description about what's wrong, what's need to be there, and attach a file with a screenshot if you want. That this is something that I'm stuck on. I'm not able to get past it. Okay, so you could do that. So support is a good thing. Another one that has been recently launched here in Edureka is the forum. So you could chat with your batchmates here. Okay, so click on the forum. It will say Introduction to DevOps, or you could choose the community as well. Community forum and your class forums can be switched by a button here on the right hand side. Okay, you could type in your questions and get the answers for it right away. That's even better. So there's a panel that sits to answer all of your queries. If you want to push it forward, you could specifically mention that I want this particular person to be answering my question, and they would be forwarding it to me. Okay, that's only done because I wouldn't be available 24/7 on emails, right? So the team is already there who would be helping you out. If they don't, if they are not let's say qualified enough, or they are not able to answer your particular question, they would definitely forward it to me. Okay, or you specify it. Cool. So that should help you out with all of your questions, right? Recordings, guides, then course curriculum, and the recordings that you would be getting after the class. That means the recent one. All right. Now let's move to our course. One more thing that I want you people to be prepared with for tomorrow's class is a VM. Okay, a virtual machine. That virtual machine is again provided by Edureka, and you should be able to get it. Or you could create a VM all by yourself. If you are aware of the software called VirtualBox, you could download that. Okay, it's free of cost. We would be using tools which are free and open source so that you guys can download it, use it for as much duration as you want, try it out, okay, without worrying about any of the licenses. So download it and configure it. The operating system that you want is Ubuntu 14.04. You could also download 16.06, but I would want server edition of it. Okay, so the reason is very straightforward. If you download a desktop edition, it would consume a lot of resources on a laptop. Since you're using a laptop or a desktop, you have got limited resources, right? Amount of RAM that you have, the CPU power that you have is limited. And when I say that I would be spinning up anywhere around 10 to 12 machines by end of the class, it means that you will need all of those virtual machines up and running, and your machine should be able to support it. For people who are low on RAM, so if they have 4 GB RAM, it's still okay. We can do some tricks to fit in those many machines in there. For people who would love to use AWS or any of the cloud services, feel free to do that, the products or any of the particular services, but I will always make a point to compare it with the cloud providers, the famous one. Okay, so whenever I get a chance, I'll compare it, the way virtual machines we are building and the way they are there. Another one is for people who are working with Red Hat or CentOS. Okay, for them, I would compare the commands, but I would still recommend you to use the VM which is being used in the class. Okay, at the first level, at the very bottom ramp up level where we are building stuff, I want everyone to be on the same page. Otherwise, you messed up on a different problem, someone else is asking some other problems. It's fine, but it takes a lot of time, and your question would not be relevant to the other people. Okay, so I want everyone to be on the same page. For Mac guys, again, you can definitely use VMs on your machine, right? For Windows, Mac users, if you are already using a different operating system, you could create a VM. That's what I'm saying. You install Ubuntu inside of it and work on Ubuntu boxes. All right. Mac would not be covered, by the way. There's a question here, a concern from Siddharth that Edureka OVA is on CentOS and not Ubuntu. Well, I was told that the new one is on Ubuntu, so let me get it fixed for you. it would be uploaded soon. So it's on Ubuntu. The version is Ubuntu Server Edition 14.04. Okay. All right, guys. Thank you so much for being with me for so long. I'll meet you again tomorrow at the same time with a new module. And I hope everyone comes prepared with it so that we can have more targeted questions. Cool. Have a great day ahead. I'll see you tomorrow. Thank you so much.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!